All right, hopefully we can build off of our stuff from Tuesday, correct? Um, Even though this says day 3, it's really only day 2 of the notes, like our second concept. And I'm going to try to break this down into what's going to happen to you next week on Monday, which you're going to have to factor in order to solve. We'll have some factoring stuff, I think, a little bit in tomorrow's note stuff, and then definitely we'll be talked about Monday. But I kind of want to talk about it now, where you're going to have a trig equation equal to 0, and then what you have to do is factor it, and it's going to factor like polynomials, and you'll end up with these two sets of parentheses. And I guess that's all I'll say about it right now. Maybe number 2, I'll talk about what that factoring will look like. And it shouldn't cause confusion. It actually should be setting your mind up why we're doing what we're doing today, and then how that's going to progress to actually 2 lessons from now. So, well, 1 lesson from now, as we're going to take a day to just try to get you to see if you can do some things correctly. So when you got this down to this, like when you had polynomials and you had something like x minus 2 times x minus 3, or let's say x plus 3, we'll mix it up a little bit, equals 0, you used what's called the zero product property, ZPP, which said if this times this equals 0, the only way that's true is if this equals 0 or that equals 0. And then you solved each one individually, and then for simple algebra, you were done, because those were the numbers that when I take 2 and I plug it in, 2 minus 2 is 0. 0 times 5, that's what happens when you plug in 2 in there, is still 0, so it solves that equation. Same thing with negative 3. So that's the basics from grade school. I'm sure you did those basic equation solvers. Maybe not zero product property, but some, yes. So that's what we do on this. So imagine you had to factor, and then you get this. There's no factoring today. They're all in factored form. And we're just trying to get you to, wax on. Anyone? Wax off. Let's get these basics down, and then we can move on and get to more complicated stuff. Well, now we're back to Monday, and I'm going to go over this fast now. And hopefully Monday is solidified after 2 days. I'm sorry, Tuesday. And then Wednesday, practice on it. This is x over r. Wait a minute. How do I get an x over r like that? Y would have to be 0. So this is going to be just this answer. It's a unique one because y would have to equal 0 through the Pythagorean theorem. So this is just 0, and then I'm going from 0 to 360. But then I'm going to find all solutions and just talk about that as we go. So I'm going to have 2 sets of answers here. So I'll do the ones in red that are just the between 0 and 360. Then this one, you add 1 and divide by 2, and you get this classic cosine of theta is 1 over 2. Cosine is Kixer. We should know this already, or, we got our review on that taken care of. And then what does that mean? Y is, the way I'm looking at this, y is root 3, and that is the reference angle side. Told you that over and over again on the first set of notes. So what has a y value that's opposite root 3? And that's a 60. So what I have now is a 60, and where's cosine positive? We got to play the ASTC game, and hopefully you get good at this, that it's 1 and 4. So the 2 answers in degrees for this are 60, and you got to go this way, go to 360, but then jump back 60 degrees. That's what the reference angle is. So that's 300. So this is all the answers between 0 and 360 for this one equation. So there's 2 parts to it. Well, now I got an issue. How do I write all of these answers? Well, none of these are connected in any way where they're the same distance away. I'm going to write this over here, then erase it. Here's 60 degrees, here's 300. Here's 0 degrees. There's no way I can write an expression that connects all 3 of them, so let's get it over with. Here's all the solutions. This is why I decided to do this way, because it's easy. To get all of these answers, you either have 0 degrees, or it's 360 degrees, or it's 720 degrees, or it's negative 360. blah, 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 blah. That's what the 360N is. It's the generator for all those answers. I'm not going to over-explain that anymore. And then 60 and 300 have no special way of connecting them. Or I told you, it's tangent and cotangent where we really have the special way of condensing the answer. So there is all answers. So just between 0 and 360s in red, all answers is in green. And I just wanted to cover that way instead of doing two examples, just showing how to show those answers in different ways. Alrighty then, let me take a break for a second. Forgot to say yeehaw when I did that lasso, sorry. All right, next, here we go. Well, okay, I said I was going to say this too on this one, and we're going to do the same thing. Degrees, 0 to 360, but then, show what all solutions would look like, which ain't no thing, chicken wing. You know where this comes from? This comes from 4 sine. I said I was going to do this. This is what Monday's question is going to look like. 4 sine squared theta minus 1 equals 0. Now, if you're this confused, you put your earmuffs on and don't listen to this part, but that's factoring by a difference of 2 squares. 2 sine times 2 sine is 4 sine squared, plus minus gives me opposites there. 1 times negative. So on Monday in two days worth of stuff, you're going to have to take this and break it down and factor it, then use the zero product property. And I hope you're fast with zero product property. This is equal to 0, you add 1, divide by 2. This is equal to 0, you add 1, wrong. You subtract 1 and divide by 2. Now I just realized we're going to get something special for all solutions, but we'll simplify it here. Both these cases, this is y. And then this is, I hit R in my head and I put an R there. And then this is R. So you have to understand, for this first one, all students, for this first one, I got quadrant 1 and quadrant 2. For the second one, where is sign negative, that's in 3 and 4. So that's another thing that's special about this kind of thing. We're going to get 4 answers for this one equation because of the 2 different parts using the zero product property. And what is the reference angle that is opposite 1? The answer is 30s. So you need all 4 30s. 30 degrees. Remember, for those that are really still challenged on this, there's 180, jump back 30. That's the reference angle. That's 150. Jump forward from 180, 30 degrees, that's 210. Go 360 and jump backwards, that's 330. So there is all the answers between 0 and 360. That's for this first set of directions. For the second one, well, now we do have something special, and you're probably not going to like this, but it could be you just add 360 to all these answers. But let's look at a couple of them. Let's look at 30 degrees and 210 degrees. How far away are those away from each other, everybody? 180. Then let's look at 150 and 330. How far away are those away from each other? 180. So you wouldn't be wrong for all answers to add 360n to all 4 of these, but because 30 is 180 away from 110, I can do that and I don't have to write that one as adding 360 to it, because 30 plus 180 does land on that one and generates those angle measures from there to there. Then the other one, you could either pick 150 or 330, but usually pick the smaller one. And I'm telling you, on the multiple choice, it's going to be the 150. 150 in. I just want to make sure I'm fine on this, that they're not all the same distance away. Again, it only happens with tangent, cotangent. You get something special that way. But from 30 to 150, they're 120 away. So that's not the same. So that's why I can connect these with a 180 generator and these with a 180 generator. So what I'm telling you is you won't get 4 answers plus 360n on all answers on this one, because so many answers happen. 2 sets of them are 180 away from each other. Gonna keep flowing. All right, so we get this one. Oh, interesting. I did this on accident, but that's okay, because it can happen. And actually, when I did a worksheet generator, they had a lot of these types of answers. So zero product property. By the way, plug your ears if you don't want to think about factoring. On Monday, this is what the question will be. It will be secant squared of theta minus 2 secant of theta. And then that equals 0. And then all you'd have to identify is that this is a, anyone? G, C, F, a greatest common factor of a secant. Okay, so again, this is it really should be mentioned why we're building this in the way we are. We're just trying to get you to understand using the zero product property on one equation that actually has two sets of parentheses or two different things. You got to actually solve each parts of those. Okay, this is what I was blabbering about. It's the first time I had this happen. Wait a minute. How could secant, by the way, is related to cosine, which cosine is x over r. So that means this is r over x. How in the world could r over x be that be a possibility? So we're going to have to drop that out. And I may have made an invalid question. So this is a no solution part of this. What I'm going to do is going to solve this one and then actually see if it actually does end up solving. Because once I get this no solution part, I think the whole thing is jacked up. But let's go ahead and put this here and solve this one and see if I did make up. Because I had to make up these questions myself and I didn't think about certain things. So, but let's put this part here and make sure that these solutions solve the overall equation, which, you know, we should do anyway. 2 over 1. All right. So that is r again, and this is x. Okay, that is one that exists. 1, 2, y would have to be root 3 through the Pythagorean theorem. So we're going to get some answers that work here. Yeah, we're going to be okay. Never mind. So y being the opposite side of root 3. The reference angle, of course, is a 60. And again, we're in the degrees. Just had to double check. Between 0 and 360, so I'll go in red for my coding here. So opposite root 3 is a 60. And then where is cosine, right? Secant. Positive 1 and 4. So my two answers are going to be 60 and 300. Sorry, I had to think there for a little bit. Remember 300? You go 360, then jump back 60. That's the reference angle, the one connected to the x-axis and, you know, touching the origin. So that's why that's 300. Now, do these answers work when I plug them in? Well, the idea is the secant of 60 is 2, right? And that's true. 2 minus 2 is 0. The secant of 60 is 2 here as well, but 2 times 0 is still 0. So these still work. It just so happens that this part of the, you know, zero product property didn't lead to valid solutions. But this one did, because both of these answers turned this set of parentheses into 0. And 0 times whatever is still 0, so we're okay. All right, so here's 60 and here's 300. So to do all solutions, like I said, I'm trying to do two things at once, so I have to redo examples. These are not connected in any special way, so we do get to do the just tack on a 360n. I'm not going to explain that anymore, all right, for time purposes. So, done with that one. Okay, only do a couple of radians, and then we'll go on to what another section of questions I think are important. Okay, we got it. So let's move on. Tan of theta equals add 1. And then tan of theta, well, this is interesting. Tan of theta equals add 3 and then divide by root 3. I think I made this a little too complicated. I wanted something a little different to happen. What I'm going to do is rationalize that denominator, and then we'll see what we end up getting. We get 3 root 3 over 3, which is just root 3 over 1. Okay, all right, so here we go, 1 over 1. Hey, I think we finally get one of these. I don't know why I've ignored them for so long. Y over R. This didn't get into our video on Tuesday. if I keep using the days here. That's wrong. Y over x. What kind of angle has y is 1 and x is 1? Well, let's draw that real quick. 1 and then 1. That's how you draw it. This is why this is coordinate trig. This is a coordinate 1, 1. Well, to jump back to the origin and use the quadratic Pythagorean theorem, not quadratic, that's got to be root 2. So this is our first time I've shown a 45 in our videos in this e-learning chapter 6 section. There we go. We got a 45. And we got a 45 in 1 and 3 because that's where tangent's positive. This is a positive ratio. So we're going to need those angle measures. What are the 45s in 1 and 3? Pi over 4. And all right, remember this is 4 pi over 4. Jump forward, and that's 5 pi over 4. So that's the quadrant 4, or quadrant 3, 45. Sorry with the 4s being in my head there. And then this one, sorry about this. I wanted this to work out different. It just didn't. But we got through it. 3 over root 3. You add 3, then divide by root 3. That's how you use the zero product property quickly. And then rationalize. You end up getting something much simpler. And this is an exact answer. This is the classic 30, 60, 90, where r was equal to 2. Remember what we said? What is y? The side, and that is root 3, which is a 60. And then yet again, I kept them both positive, so this is going to be the 60s in 1 and 3, which are over 3s, which is a pi over 3, and in quadrant 3, this is 3 pi over 3, jump forward, and that's 4 pi over 3. Okay, so that is from 0 to 2 pi, all of the answers. From 0 to 2 pi. How do you find all the solutions in radians? I'm going to flip it to now red is all solutions, just because of the color choices that I have. Remember I told you tangent and cotangent are special. Their angle measures are, when we have these multiple answers, are really always 180 away from each other. So don't just tack on a 2 pi n. It's actually pi over 4 plus pi n, because that's how far this is. This is a distance of pi, and that's a distance of pi. So I pick one of them and then choose pi n, and that would be the more succinct answer. And then the other one is pi over 3. Sorry, my 3 got jacked up there. Plus, same thing. Don't just tack on a 2 pi n, a 2 pi n, a 2 pi n, and a 2 pi n when these are pi away from each other. You can generate them all by simplifying the answer to a smaller version, I guess. And then also, I'm just telling you in a multiple choice, that's what's going to come up. Alrighty. Yeehaw. There, we got that one. Slide that sucker over. And then we got room for this one. I'm only going to do this one. And maybe I'll do this one. I'll do this one. So just running short on time here. So zero product property again. Cotangent of theta equals 0. Cotangent of theta equals subtract 1. Hey, yay, we got 45s again. This one's very special. Where do you get... I'm sorry. Cotangent is not y over x. Tangent is tix, so this is x over y. Now this one you got to be careful on. This is the first time this has occurred. Where do you get 0 for x and 1 for y? Well, many will say that right away. You're right. But then this could technically be plus minus 1, because 0 over negative 1 is still mathematically 0. So it's actually here as well. And of course we know these are 90 and 270, and this is the first time I've had to say this. What is that in radians? And the answer to that is pi over 2 and 3 pi over 2. So look at your unit circle to remind you of those answers. So from 0 to 360, I think I chose the green color for from 0 to 2 pi answers. We have pi over 2 and 3 pi over 2. And then for this one, hopefully we can be this fast on this. This is, again, x over y. This is when we get the 45, 45, 90. Let's just draw 1, for instance. Negative 1, and then 1. We could go that way. All right, so that'd be negative 1 for x and 1 for y, or 1 for x and negative 1 for y. Either way, look at this triangle. Through the Pythagorean theorem, that would have to be root 2. So I feel like I have to explain that because we didn't really do 45s on our last set of notes. Anywho, what are the 45s in 2 and 4? And I was going to go through that again about all students take calculus. It's got to be 2 and 4 because they're positive in 1 and 3. And that's not what I want. I have a negative ratio. Anyway, the 45s are over 4s. This is 4 pi over 4, jump back, 3 pi over 4. This is 8 pi over 4. Jump back a little bit, and that's 7 pi over 4. These are all the answers from 0 to 2 pi. So that satisfies this set of directions. Again, hammering down that this is 2 different ways of answering the question. I've satisfied that. Now, how about all of them forever in radians? Yet again, I said I was going to change that to red. Pi over 2 and pi n, because these are pi away from each other. And then same thing with these. These are, I didn't finish that side, these are 180 away from each other, which is equal to pi in radians. So pick one, and then it's pi n as a generator for that answer. All right. Okay, then I picked to do these because they kind of coincide with this, multiple answer idea. And we're going to have something like this happen to you on Monday as well. So I think many would know, what do I have to do to solve for sine squared? And the answer is you'd square root both sides. Okay? Oh, burn, baby, burn. This is one of our burns from August, my class. What happens when you square root both sides of an equation? You got to put plus minus. What's the square root of 1? 1. What's the square root of 2? Square root of 2. Which actually this turns into root 2 over 2. The reason I put this in this section, you really do have 2 cases you have to think about, but you don't have to split this up like this. I'm just doing this so you can understand better. Sine of theta equals negative root 2 over 2. And I hope that, gosh, you know what root 2 over 2 is. We can look at the unrationalized part. This is y and this is r. It's got to be a 45. So this one tells me I have a 45 in, where's sign positive? Both 1 and 2. Where's sign negative? Well, 3 and 4. So basically this just tells you you need all the 45s in 1, 2, 3, and 4. Okay, so what do they tell us to express this in? All right, good. We simplified the directions, just one thing. So all the 45s are over 4s. We're finding all the radian measures. And it's pi over 4, that's quadrant 1. 2 pi over 4 is not one of them, that's pi over 2. 3 pi over 4 is quadrant 2, not 4 pi over 4, that's pi. 5 pi over 4, 7 pi over 4. That's the answer to this question. And then going over this one real fast, cotangent squared, well, we got to do the same thing. Root, and then we get cotan of theta, again, equals plus minus 1. Now, since this is x over y, we actually have this as the same question that we just had as one of these parts, didn't we? Well, cotangent of theta just equals negative 1, but we should understand that this is again, oh boy, I didn't have any 45s 2 days ago, and now I get a whole bunch of them. This is another 45 where r has to equal root 2 through the Pythagorean theorem. Bottom line is, this is what we have. We have 45 degrees. All right, let's go through it. Where's cotan positive? And that is 1 and 3. Where's cotan negative? And that is in, guess what? 2 and 4. But ultimately, all this means is I have to have all 4 45s yet again. Shaboing. It's that same answer from the previous question. Weird. I just randomly did that, and that's what ended up occurring. So hopefully this is helpful.